Hey there folks, Mr. G back with another educational video. This is a follow-up on our previous video all about right and oblique triangles. Here we're going to be going into more of the oblique, all the ones without 90 degrees, and we're going to be learning about something called the sine law. Now if you remember in our previous example with oblique triangles, we were finding the area, but we didn't really go into how you would solve for some of these other sides and angles that are missing. The sine law is going to help us with these types of problems. If we look at the book, we're actually going to be skipping over most of 7.4. 7.4 solves these problems the hard way. There's lots of algebra, and there's a much better way of doing this. In 7.5 and 7.6, we're going to be solving these types of questions in a much easier way that avoids a lot of the algebra headache that you get from 7.4. Once we finish this, you're welcome to go back and use your new knowledge to solve the questions in 7.4. You're not missing out on anything. We're just skipping over the hard way of doing it. Today we're going to be talking about the sine law. Let's jump into it. When we talk about oblique triangles, they fall into two categories: acute, where all the angles are less than 90, or obtuse, where we have one angle that's bigger than 90 degrees. So whenever we're thinking about oblique triangles, we have to consider both cases. Our acute case looks a lot like our previous example where we did area, and the way that we derive our sine law is very similar as well. We draw a line straight down the middle from our top point that intersects our base here, and we're going to call that the height. And using this height, we actually get two different right triangles. If we focus on the one on the left here, and we're going to use sine in this case, sine is opposite over hypotenuse, so for angle A here, our opposite side is h, our hypotenuse is b, so it's equal to h over b. If we look at our other triangle on this side, using sine again, it's opposite over hypotenuse, our opposite side is still h, but now our hypotenuse is a. For both of these equations, I'll isolate for h, and since these both are equal to the same height, I can set them equal to each other. And then I'm going to rearrange a little bit, dividing both sides by b and both sides by a, and we get this equation right here. This is our sine law. Now it's not the whole sine law, and the way we can get the other part is by going back to our original triangle and rotating it around so side A is on our base. It would be like taking this triangle here and rotating it around so that this side is on the bottom instead of side C. If you do that, you get this equation. Since this is on both of these, we can combine these two equations together into one big equation, which is this one right here, which says that the sine of the angle over its opposite side is the same for all sides and angles. And this is true for all triangles, not just right triangles. Now what about our other case, our obtuse triangle? This one turns out to be a little bit harder, and you actually need to draw your height outside of your triangle here, which is a bit weird. But you can go through the same idea that we did on the left here, and you should get the same equations. It's a bit harder though, because in this case you actually need to use the idea of reference angles. I'm not going to go through it, but if you're interested, I would highly encourage you to try and see if you can solve it on your own, or look up derivations online. Let's try and solve this example here using sine law. Now this question is an example of what is called angle, side problem. This is because we're given two angles and one side. What we'll see is that depending on how many angles and sides they give you, there are different tools to solve the problem. This works well for angle, side problems. We'll talk about other cases in future videos. As always, if you're not given a picture, try and draw one. So first thing, we know that our one angle is equal to 15 degrees. We have another angle that's bigger than 90 at 113 degrees, so we can draw it over there. Our last angle is angle A, which we don't know yet, but the opposite side we know is equal to 6 centimeters. The best part about these angle, side problems is that since we have two angles already, we can solve for the third angle really easily. Recall that our last angle plus our other two needs to be equal to 180, so 180 minus our two angles that we know should give us our last angle. And this is always the first step in these angle, side problems, is to find our one missing angle. Our next step is going to use sine law. In this case, we're going to try and solve for one of our two missing sides using sine law. However, to do that, we need to make sure that one of the angles and sides that we're using is the matching pair. If you remember our formula, it's all about angles and the opposite side, and we pair them together. Since we know angle A and side A, we need to use that here. If we tried to use angle C and side C, we wouldn't know enough information to solve our equation. You can plug in your numbers if you want to at this point. I really prefer to arrange it using variables. In this case, I know I want to solve for side B, so what I'm going to do is multiply both sides by A and both sides by B to get rid of denominators. Lastly, I know I want to get B on its own. Since it's being multiplied by sine A, I can divide both sides by sine A and get my B on its own. And there's our formula here. Now I can substitute in all my numbers. Once you have all of this, you should just be able to plug it into your calculator and get your answer. Here we're going to round to 2 decimal places. First we have our unrounded answer in case we want to use it later, and here's our rounded answer to 2 decimal places. Our last step in these types of problems is the same as our second step, except for instead of solving for one of our missing sides, we solve for the other one. Again, we're going to use the pair that we know, the angle A and the side A, to help us solve for our missing side C. Again, we can rearrange our formula just like we did before, and it looks very similar just with the B's replaced with C's. When you plug this into your calculator, you should get the following, which if we round to 2 decimal places, we get 7.01 centimeters. That's the end of our second video here. Make sure you try out the homework. It's posted on Teams, and I'll see you in the next video.